He was standing up. She was sitting down.
So today we're going to be talking about the properties of logarithms. And in doing so, we're going to start with the first property, which is the product property. So I'll give you a chance to copy this down and then we will discuss it. Is the product property. So for all positive values, m, n, and b are those values. And b not equal to 1, like we've always discussed, or we've been discussing, that you cannot have a base that is equal to 1. So if we take log base b of m times n, and that's going to equal log base b of m plus log base b of n. This is very similar to the exponential rules that we've learned way back, and that is, if we multiply powers with a common base, we add the exponents. Not only is it related, it is intimately connected. They're basically the same thing. Now, I'm not going to go through the proof of this, but the proof is actually in your book on page 611. The proof of why this works is in your book, and it is directly related to the product to the property of exponents, which says if I multiply powers with a common base, I add the exponents. They go hand in hand. Now here's an example, just a basic example where we have log base 7 of 3x. That's equal to log base 7 of 3 plus log base 7 of x. I just broke up my product into two separate terms, two logs with the product broken into parts. Okay, any questions about that? We're going to see how this all works, how we're going to use this to solve equations later on. Okay, let's continue. Okay, the quotient property. I'll let you copy this down, then we'll discuss it. So the quotient property says for all positive values, m, n, and b, where b is not equal to 1, the log base b of m over n equals the log base b of m minus log base b of n. So just like when we divided powers with a common base, we subtracted the exponents. We're doing the same thing here. That and this are intimately connected. And if you want to see a proof of it, you can look at page 612, I believe, to see the proof of this property. Okay? All right. Any questions about that? And I just put a little example here. Log base 11 of x over 12 equals log base 11 of x minus log base 11 of 12. Okay? Questions? All right, let's move on. Okay, the next property, and this is the last property today, is called the power property. So go ahead and copy this down. The power property comes in very handy for lots of different simplifications of logs. We're going to use it here in just a few minutes. But it says for any real number p and positive numbers m and b, where b is not equal to 1, again we see b can't be equal to 1, the base is not equal to 1, the log of b, log base b of m to the p exponent equals p times the log base b of m. So all that's kind of wordy, but all it's saying is if I'm taking the log of a number and that number has an exponent, then that exponent can come out front and be multiplied to the whatever the log is. So here's an example. Log base 8 of 11 to the 12th. When you simplify that, the 12 comes out front, and so you're multiplying 12 times the log of 8 times 11. Log base 8 of 11. Now think about it. 11 to the 12th is really 11 times 11 times 11 times 11, 12 times, right? So if I were to write that out as a product, I could actually simplify that or convert that to the form that we learned in the power, not the power property, but the product property, which says we can take a product and just write it as sums. So in other words, I could do log base 8 of 11 plus log base 8 of 11 plus log base 8 of 11 12 times. Now you would never want to do that. So instead, why don't we just say 12 times log base 8 of 11? All right, it becomes exactly the same thing. It just saves you all that time and headache of writing it all out. So there will be instances where we use this and it becomes very useful. All right, let's look at some examples. So over here, let's take a look at page 614 in our book. This is the guided practice, starting with number 5. Now, when we work these problems, we're going to use the properties that we've learned. We're going to use 2 different properties in this first problem. The first property we're going to use is where we're going to separate the product. All right? But at the same time, we're going to use the power property, which puts that 2 in front. So here we go. Log base 4 of x squared times y can be simplified to 2 times log base 4 of x plus log base 4 of y. Okay? Everybody agree with that? All right? Let me change colors here. Okay, now what can we do in the next problem with that 3? Log base 3 of xy to the third. Where can that 3 go? Where can it go? In the front. So we can first write it as 3 log base 3 of x plus, how about we put it in parentheses, put the log base 3 of x plus log base 3 of y in parentheses, because I'm basically doing that for both. When I put that 3 in front of the log, it's the log base 3 of xy. Well, that xy can be broken up into a sum. So the 3 stays out front. So the 3 times log base 3 of x plus log base 3 of y. And that's one way to simplify it. And you can distribute that 3 onto each of those parts. All right, look at number 7. Number 7 does not have an exponent. It's a quotient. So the quotient property says to use what operation?
Multiplication.
No.
Division. Subtraction.
Subtraction. So division and subtraction go together when it comes to these exponential and logarithmic properties. And addition and multiplication go together. So we're going to subtract. So I'm going to say log base 5 of AC minus log base 5 of B. Now I could also break up that AC, right, into a sum, but I'm not going to do that. Okay, look at the next one. Where's that 3 going to go? To the front. Where's that 4 going to go? To the front. But they're going to go to the front of their individual parts. So you're going to have 3 log base 11 of x. And then plus what? 4 log base 11 of y. So the 4 goes out in front of the y term, and the 3 goes out in front of the x term, if you will. All right? All right, let's take a look at some other examples. Okay, here's another example of a logarithmic equation that is broken up according to, actually I've already simplified it. In your book, it tells us what these logs are equal to. And so what we've got is this. Log base 2 of 3 is equal to 1.585. Log base 2 of 7 in your book, it's telling us, is equal to 2.807. So what I've done is we've taken the log base 2 of 7/3, broken it up into a difference because we're subtracting according to the rule, quotient property. And now I'm going to substitute log base 2 of 7 is actually the approximation 2.807 minus log base 2 of 3, and this is what the book is telling me these answers are, y'all. If you don't have your book, in the instructions, it tells us to approximate log base 2 of 3 as 1.585. It tells us to approximate log base 2 of 7 as 2.807. So I'm not just making this stuff up. So then we can simplify 2.807 minus 1.585 comes out to be 1.222. All right? So that's just a little exercise that the book has us do. Now, look at number 10. Number 10 says log base 2 of 36. Now, the only part of this that I'm given that's going to apply to log base 2 of 36 is that log base 2 of 3 is 1.585. 3 is a factor of 36. 7 is not. So I can't break 36 up into, something times 7. It doesn't work. Not with whole numbers. So I can break it up into 3 times 12, right? So I've broken it up into 3 times 12. But what else can I break it up into? I can break the 12 up into what? 3 times 12 is 3 times what? 4. So I'm going to get rid of that. I'm going to say 3 times 4. Now, log base 2 of 3 is 1.585. Well, I've got 2 3's here. So it's plus 1.585. Plus, I don't have an approximation for log base 2 of 4. Not really anything I can do with that. So I'm just going to leave it as log base 2 of 4. And I can add these together. And when I add 1.585 plus 1.585, I think I get 3.17 plus log base 2 of 4. Alright, so in number 12 here, we are actually solving an equation using the properties, one of the properties that we've learned today. And the property that we're going to be using is the product property. So notice that all of the logs have the same base. That's great. But I want it, in order to solve this thing, I want to just have one log base on the side, on each side. I don't want to have log base 2 plus log base 2 equals log base 2. I want just one log base on each side in order to use the equality property. So how can I rewrite this left side according to the product property that we learned today? What would it look like? Excellent. So smart. Log base 2 of 5x, because it's 5 times x, equals log base 2 of 15. Now that I have the same base, cancel them out. 5x equals 15, x equals 3. Ta-da. All right, questions about that? Okay. Okay, now work this problem. I'll give you a few minutes. Using the rules that we've been discussing, here we see the quotient rule come into play. So since I'm subtracting powers, I'm subtracting logs with a common base, I'm going to write this as 16 over 2t, because that's what we're dealing with, a quotient. The log of a quotient equals 2. But what I want to do to solve this is just basic. This is just a basic equation. Cross multiply. So this is really 2 over 1. So I'm going to multiply 16 times 1 and get 16. 2t times 2 and get 4t. And so t equals 4. Okay? Now, if you use the properties correctly, it's an easy equation that you'll have to solve in most cases. The problems that we do anyway. All right, let's take a look at another one.
How do you know?
Hold on, let me copy that down really quick.
Okay, so listen. We're adding the logs of the same base. So that tells you to do what to those numbers?
So you go ahead and add them together.
To multiply them, right?
It's certain to be
So 7n
minus 2.
minus 14. 7 times n minus 2 is 7n minus 14. Equals
Log.
6n. I just went ahead,
You went ahead.
just like we do when we solve exponential equations with a common base. Sometimes we just cancel them out.
You bad, man.
I just skipped a step. Is that bad? All right. My teacher in college, he would have said, yeah, don't skip the steps. All right. So 7n. Subtract it from both sides. That gives you negative 14 equals negative n. But I don't want negative n. I want positive n equals 14. Okay? N equals 14. All right. So these are your assignments. This is your assignment for homework.
Oh, that's easy homework,
You know what? I do need to do this example real quick also. All right. 15. Number 15 from your book. Notice how I've got log base 2 on both sides, but there's also this 1. Well, I don't want the 1 on the same side as the logs. I want the 1 by itself, and I want the logs on the same side. So what I'm going to do is swap these two things. So when I do that, I have log base 2 of y plus 2 minus log base 2 of y minus 2 equals 1. I just swap them and change the signs, right? Now that I've got the log base 2's on the left, with the subtraction, that tells me it's going to be a quotient, right? So what is the quotient? It's going to be log base 2 of what?
Is that Y?
Y plus 2 over y minus 2. Now, can I cancel anything out? Can I cancel the logs if I don't have logs on both sides?
No.
No. So now I've got an expression that needs to be converted to an exponential equation, right? So how am I going to do that? 2 to the first, my base raised to the first, equals y plus 2 over y minus 2. Now how am I going to solve this? How about cross multiply? So 2 to the first is really just 2 over 1, right? So when I cross multiply, I'm going to have 2y minus 4 equals y plus 2. Now solve. Subtract. So y minus 4 equals 2. Add 4 to both sides. Y equals 6. So it looked ugly, but it wasn't that ugly.
It was just like me.
It was legal, but it wasn't like this.
All right, so this is your assignment.
Hold on.
Hold on, let me finish copying.
Okay?